Welcome to this first installment of a video series explaining systems of equations. So let's start off with the definition. A system of equations is a set of equations, some number of equations. It could just be one equation. It's a set of equations that constrain solutions. Now it could be one equation that constrains solutions. It could be two. It could be 170. Any number of equations could be grouped together to say, this is what x and y can be, or this is what x, y, and z can be. But for right now, we're going to do two equations. Here's an example of a system of equations. We've got these two equations. Both of them have x and y for variables, x and y for variables. So this is a system of equations where x and y are our variables. These are both linear equations because x is to the first power, y is to the first power. This first equation, if you recall, is in standard form where the coefficients on x and y and this constant are all integers. And then the x's and y's are on the same side of the equation and the constant is on the other side. This equation is also a line equation. It's in the form, the slope-intercept form, where we know the slope and we know the y-coordinate of the y-intercept. Okay, so these are two lines. They may be lines that intersect each other, something like that. I don't know, I haven't graphed them yet, but maybe they intersect each other, or maybe it's two lines that are parallel and they never intersect each other, like that. Or, well, those are kind of our two options, I guess, in a plane. You could also have lines in space that don't intersect, like this. Those are called skew lines, but this is assuming you have an xy coordinate plane, which is flat. So you're either going to have parallel lines or you're going to have intersecting lines. The one other thing you could have is perhaps these equations are actually the same line. So you get one line, but its equation is written in two different forms. If that were the case, then any point on this line would also be a point on that line. Okay, so we need to talk about what is a solution to this system of equations. Okay, a solution to a system of equations is any point that satisfies all of the constraints. Another way to put that is that a solution is going to be a true solution of each of the equations in your system. Okay? So if you have two lines that are actually the same line, then any point on one of those is also a point on the other, and all of those points would be solutions to the system. If you have parallel lines like this, then there will never be a point on this line that is also a point on that line, which would mean the system would have no solutions. Or the most common case is that you've got lines that cross each other, and then in that case there's only one point. There's exactly one point at which this equation would be solved and the other one would be solved. So that case would only have one solution, exactly one solution. And the solution would be the x coordinate and the y coordinate that is a solution to both equations. Okay, so let's look at our particular case and see what we get. We could do this a number of ways. One way we could do this is rearrange one of the equations to be in the other one's form and then compare. If they're identical, then any solution to the one will be a solution to the other. All right, so let's let's see what happens if we make the standard form into slope-intercept form. In order to do that, we have to isolate y. So we're going to subtract 3x, and we get negative 4y equals negative 3x minus 5. Then we need to divide by negative 4 because that will undo the multiplication. So we get y equals 3/4 x plus 5/4. How is that? Well, negative 3 divided by negative 4, negative divided by negative is positive. 3 divided by 4 is 3/4. Negative 5 divided by negative 4, negative divided by negative is positive. 5 divided by 4 is 5/4. Okay? So now, if we compare this equation to this equation, they're clearly not the same. We've got different slopes. One has a slope of 4, one has a slope of 3/4. One crosses the y-axis at 0, negative 2. The other one's at 0, 5/4. So, if we want to graph those, it would look like this. We'll graph this one first. We've got a point at 0, -2, and we go up 4/1, that's our slope, up 4/1, so we can make this line like so. That's this line, and then the other line, it crosses the y-axis at 5/4, which is 1 1/4, so that's maybe about here. The slope is 3/4, so it goes up one, two, three, for every 4 to the right. So that'll put a point over here, and we can connect those dots like this. So whatever this point is right here, that's the only solution to this equation. We know there's exactly one solution. Now, in future videos, we will figure out how to find that point. But for right now, the first thing that you'll be asked to do on Khan Academy is find solution. Just confirm whether a point that is given to you is a solution of the equations that they gave you. Okay, so in this particular one, looks like they give us the point 1, 2, and they ask us, is this point the solution to the equation? Well, graphically, it looks like 1, 2, maybe. It might be. I mean, I hand drew this, so we don't know for sure from my graph, but it looks like it could be. In order to find out, all we have to do is substitute 1 in for x and 2 in for y in each of these equations and see if it's true. So let's do that. All right? We'll use the original equations in case I made a mistake in my algebra getting this this equation converted into y slope-intercept form. So we'll use the original equations. So we put 1 in for x, and that's 4 times 1 is 4. So 4 times 1 minus 2 is supposed to equal y equals 2. Let's see if that's true. 4 times 1 is 4. 4 minus 2 is 2. So yes, this is correct for that one. So it's possibly the answer. Now we'll try on this other one. We have 3 times x is 1 minus 4 times y is 2. And that is supposed to equal -5. Let's see what happens. This is 3 minus 8 equals -5, and yes, that is true. So, because both of these equations are solved by the coordinates x equals 1, y equals 2, that point is indeed the solution, the only solution to this particular set, this system of equations.